Welcome to a special episode, True Set Free. I'm Matt Lewis. You know Pastor Steve Whinery. You don't know this guy. This is Dr. Jason Lisle. I have his bio up here. He's a Christian astrophysicist who researches issues pertaining to science and the Christian faith. Here's the deal. We're going to be talking about a lot of issues, and so if you're a Hanford person, you're going to love this, and you'll probably follow along. If you're a simpleton like me, it might go over your head, but that's okay, because I like it that people that are smarter than us still believe the Bible. And so that's what we're here to talk about. For you guys that are local, I also want to tell you that for our 3 services tomorrow morning, which is 7:30, 9:15, and 11 o'clock, Jason's going to be here to speak and teach on Sunday service. So encourage you to come out and listen to what he has to say. I'll let him just kind of talk a little bit about himself and what he does so you guys know. And then probably Pastor Steve and him are going to do most of the conversation, and we'll just see what happens and see what the Lord does. So, Jason, tell them a little bit about your background and what you do.
Okay, well, the most important thing is I'm a Christian. I've trusted in Jesus to pay for my sins and repented of my sins. And out of gratitude for that, I try to live for Him. And my secondary interest would be science, and that's what I majored in when I was in college. I majored in astrophysics, minored in mathematics, and then I got my master's degree and PhD at the University of Colorado in Boulder in astrophysics. So I study outer space, anything along those lines. My specialty field when I was in school was the surface of the sun and how things moved on the surface of the sun. And now what I do is I try to show people that God's Word is true from the beginning, and I try to show them that science, when you understand it, lines up with what the Bible teaches, because there's been this propaganda campaign by the secularists that to be scientific, you can't be Christian.
Absolutely.
And that would come as a shock to the founding fathers of science, most of whom were Christians, and certainly were motivated by a biblical worldview. So that's what I try to do, is to help people over those stumbling blocks, particularly in the area of origins. I specialize in defending the literal history of Genesis.
All right, I have a bunch of questions, but I'll let Pastor Steve start and kind of guide what you want these guys to gauge from him in the hour that we have. So kick it off, and we'll just get into it.
Okay, well, why don't we start with some simple stuff? You know,
Okay.
as far as the obviously we've got an issue with evolutionists as far as the age of the Earth goes, and not only the age of the Earth, but the age of the solar system, and also the age of the universe. And generally speaking, obviously when this is brought up in school, they don't give a creationist viewpoint,
Right.
and they're never talking about any of the young Earth or young universe evidences. And so, can you give us a quick rundown? Yeah, let's start with the solar system.
Okay, well,
Yeah.
I think we need to, just at the start, point out the Bible does teach what we might call a young Earth or a young universe. It's 6,000 years old. It's not young, but
Yeah.
it's young compared to the secular view. And there are various lines of scientific evidence that would confirm that. And usually the way that we present these arguments is we'll do what's sometimes called a reductio ad absurdum, where we'll take the assumptions of our opponents, those who believe in the billions of years, and show that even if we take their assumptions and their starting points, you end up with an inconsistency. You end up with an age that's much less than that. One example would be the recession rate of the moon. The moon is actually moving away from the Earth due to tidal forces. You might know the moon pulls on the Earth's oceans, that causes tides. But then the Earth, because it rotates faster than the moon orbits, the tides get ahead of the moon, they pull forward on it, and that causes the moon to gain energy and therefore move away from the Earth slowly, and consequently slows the Earth very, very slightly. And so if you run that equation backwards, and we can measure that today, we know it's about 1.5 inches a year today. So it's not a huge difference. And so you run it back 6,000 years, the moon would have been about 750 feet closer to the Earth, which is not a huge deal considering it's 240,000 miles away. But if you run it back billions of years, and you have to do the math right, because the tidal bulges would be bigger when the moon's closer, and therefore the rate would be even faster in the past. You have to use calculus to do it right. But you do the math, and you find that the Earth and Moon would have been touching at about 1.45 billion years in a hypothetical past.
Right.
And that sounds like a lot, but in the secular view, they're supposed to be 4.5
Right,
billion years
exactly.
old. And so that's an inconsistency with the secular model, but it's perfectly consistent with the biblical timescale of the Earth and Moon.
Right, and that's not even counting the Roche limit.
Right, because even before that would happen, the moon would be shredded.
Right.
Yeah.
Yeah. So, one of the questions that I've had lately that I've just kind of been watching in the news are some of the things that are happening with the sun. Are you seeing anything that's different than what's been happening for the last couple of 100 years, or?
Nothing catastrophic, but the sun does apparently go through natural cycles. We know it goes through a 22-year magnetic cycle, and that's why the sunspots peak every 11 years, actually, because it's the sun's magnetic field flips every 11 years, and that's something that I studied in grad school, and it's fascinating. But not all cycles are equal. There was a period in the 1600s where there were very few sunspots, even at solar maximum, the place where you'd normally have lots of sunspots. And that corresponded with cooler temperatures, at least in Europe and perhaps globally. And so, and we'd expect that because when the sun has more sunspots, you might think it'd be a little cooler, but it's actually, the rest of the sun overcompensates. And it actually puts out a little bit more energy during solar maximum when there's more sunspots. And so you'd expect Earth's temperature to be a little warmer during that time. And so, but the last couple of cycles have been weird. We haven't had as many sunspots as normal, and so we're thinking, is this another kind of Maunder minimum where we're going to go in another one of these? If so, that might correspond to cooler temperatures on the Earth for a little while. So it'd be interesting to see if that happens.
Yeah, that is interesting. Especially in light of, one of the things that we obviously do all the time when because we go through the Bible is you get to passages like the passages in Revelation 16 where it talks about the sun burning people. And, they're talking about global warming right now, but that's real global warming, at that point. And, is there anything that you're seeing that might be a precursor to that, or is it just pretty normal?
Yeah, I would say nothing along those lines, nothing that's catastrophic. We do have a promise from God that as long as the earth remains, there will be seed time and harvest. So now on Judgment Day, all bets are off. There's no stopping that global warming. But until then, there will be a certain degree of stability. And we do see that in the sun. And the sun is unusually stable, too. When we compare it to other stars tend to pulsate. The sun has, I guess we might call them pulsations. It has a 5-minute sort of oscillation. It's very, very mild. And it has flares, but they're relatively mild. Some other stars have super flares, which if that happened with our sun, at the very least it would wipe out our satellites. But could it cause damage to life on Earth if it were powerful enough? Yeah. So the sun
I
is
had a question
stable.
about that because I always hear, and I'm from like the law enforcement background or whatever, but I always talk about EMPs, solar flare EMPs. Is what they're seeing, what we see on the news, is that hyped up, or is that legitimate to where you could have a solar EMP and same thing where it like takes out the electrical grid and takes us back 200 years or something?
It could happen. It's very, very rare, and we don't really know because since the industrial age, really since the Industrial Revolution, we haven't had a mega flare like that.
Right.
But yeah, it could be enough to cause some damage. Would it be enough to wipe out all systems on Earth? No, but it could cause damage. Yeah, that could happen.
Right.
That could happen.
And so from Steve's question, because I had on there too, Revelation 16, when we get to Revelation, God's pouring out his judgment. It's the connection with the sun heating up, you think is a spiritual thing? Or is there some type of scientific things that going on that he uses for that judgment?
Revelation's tricky because it's the most symbolic book of the Bible. It uses all kinds of Old Testament imagery. So I would avoid reading into it, sort of the newspaper, what's going on today. I'd avoid that. I don't think it's an astronomical phenomenon that it's referring to. I could be wrong about that. I'd have to look up the passage, but yeah.
Okay. So then there's the issue of, well, do I want to go there yet? Well, yeah, I guess I do. Since you're an astrophysicist, there's the issue of distant starlight, and so this is one of those things that anybody who's into science at all has a question on. It's something that I had questions on when I was a young believer, and obviously we have a very large universe, and it's getting larger all the time. As far as we're seeing things further out. I was just reading not too long ago. I guess the most distant object is about 32 billion light years away. The light from it, they think started about 13.4 billion light years ago, or billion years ago, to get here. And so obviously that's huge. And you have the speed of light coming towards the Earth, and as well, we know what the speed of light is, and so the problem is if these things are this distant, then how did light how did light get here more quickly if the universe is young? So.
Yeah.
You want to jump in there?
Sure.
Okay.
Yeah, yeah, we're jumping in the deep end now.
Okay.
Yeah, so that's sometimes called the distant starlight problem, or
Right,
the distant
yeah.
starlight issue. It's not a problem if you know something about physics, but very few people know enough about physics to be able to really deal with that. And a lot of times people will propose a simple solution that it's just not going to work. Some people have proposed that maybe the speed of light was faster in the past, and that was a neat thing to try, because sometimes evolutionists assume that something was the same in the past as it is today, when in fact it was more rapid in the past. Erosion rates for canyons and things like that on Earth that we know would have been much more rapid during the flood, for example. But there's good reasons to think that the speed of light has always been what it is today.
Let me ask you a question on that,
Sure.
just before we get going. Obviously, well, not obviously, but I do know from history that people thought that the speed of light was instantaneous at times.
Yes.
And then we find out it's 183,000 miles per second, right? Somewhere in there. And one of the questions that I've always had is, why the speed limit?
Yeah.
Does this have to do with the permeability of space and that kind of thing? Because obviously light goes slower when it gets into water and that kind of thing. Does it have something to do with that? And one of those questions for me has always been, we have limits in physics, and the speed of light is one of those. It's really interesting because it's just there. That's what it is. And so can you speak to that a little bit?
Yeah, the speed of light is not like other speeds. It's not arbitrary. It's set by God. It is apparently a property of the universe. And what it does is it sets the relationship between space and time, really. We measure space with things like meters, lengths in space with meters. And we measure lengths in time with things like seconds. If we used the same units for both, the speed of light would be 1. But because we use different units, if you want to use miles and seconds, it's 186,282 miles per second. So what that's doing is it's saying this 186,000 miles is like 1 second in time. That's setting the parameters of those two. It's sort of an equal distance, if you will. And everything depends on, not everything, but a lot of things depend on the speed of light. The relationship between electric fields and magnetic fields depends on the speed of light.
Now, is that arbitrary, or is that something where they've just taken a convenient measurement and plugged it into the equations? Or is that something that is absolutely necessary for electromagnetic fields and, Lorentz equations?
Let's put it this way: if God had made the speed of light different, the strength of the electric field to the magnetic fields would be different as well. So there's a range there, and we don't know if it's too much different if atoms would even be possible, because atoms, the electron shells have a certain distance due to the strength of the electric force. You mess with that too much, and you don't get the right. Certainly, the periodic table would not be what it is today, and might not even exist. You might not even have atoms. So it is a design feature that the speed of light, given the way God made the other laws of physics, the speed of light has to be pretty close to what it is. And that's a good argument for why we think it hasn't changed.
Right, exactly.
So it's because matter still exists. It sets the relationship between mass and energy as well. So if you decrease the speed of light, the equation E equals mc squared, that's relating energy to mass. So if you decrease the speed of light, either the energy of everything in the universe would drop or the mass would increase. Either way, the Earth would fall into the sun because the sun gets more massive, or the Earth loses energy. Either way. And so it is an important property of the universe that speed of light c is exactly what it is, 186,282.397 miles per second.
Okay.
Okay, so is there a simple way to describe why the speed of light affects electromagnetism and why it's so important and all those other things you just described? Why is that?
Yeah, it might be better to kind of turn it around and say the relationship between electric fields and magnetic fields determines what the speed of light is.
Okay.
Light is an electromagnetic wave. And basically, given what we call Maxwell's equations, if you take an electric field and you move it, a moving electric field will create a magnetic field.
Right.
And if the electric field moves in the right way, it'll create a magnetic field that also moves. The magnetic field then, a moving magnetic field, will create an electric field. And if you do this in a sinusoidal fashion, kind of, this just like a regular wave like that, the sinusoidal electric field will create a sinusoidal magnetic field, which will create a sinusoidal electric field, which creates a magnetic field, which creates an electric field. That's what light is.
Okay.
It's one field creating the next, creating the next, creating the next, and it propagates through space at the speed determined by the signal transmission of the electric and magnetic fields, that's what the speed of light is. So it's a built-in property of the fabric of space-time, if you will, that electric fields and magnetic fields propagate at that speed, and that determines what light moves at, basically.
Gotcha.
And any particle that has no rest mass has to move at that speed if it has any energy at all. So it really is a unique speed. It's not like others where you can speed up or slow down. Light has to travel at that speed. And anything that has mass has to travel less than that speed and can't reach it.
And so this is from my Chuck Missler Bible study days, but waves, particles through water, it's the same constant speed no matter what environment you're talking about?
Well, in water, it's no longer traveling just through the fabric of space. It's traveling through the fabric of space and a substance. And so the speed will be reduced. The speed of the group wave is reduced in a substance. So in water, light travels at about 75% the speed that it travels in vacuum. So it does slow down when it goes through a substance. When we talk about C, this 186,000 miles per second, that's in vacuum. And that's where it reaches its maximum speed, is in vacuum. In a substance, it will go slower.
Interesting.
Okay, so back to speed of light and distant galaxies.
Yeah. It turns out, I keep working on a way to get a succinct answer to this, and I haven't succeeded yet. I'll do the best that I can. Because of the simple answers that people like to give. People often prefer simplicity to truth. Mm-hmm. The true answer is a little bit complicated, but it has to do with the fact that we can't measure the one-way speed of light. At least I believe this is what the answer is. When we talk about C, the speed of light being 186,000 miles per second, what that really means is if you were to take light and send it out 186,000 miles, bounce it off a mirror and bring it back, and measure the total time, it would take 2 seconds to do that because it has to travel that distance twice. Right. And so 186,000 times 2 divided by 2 seconds, there's where you get the 186,000 miles per second. That's an average speed. Most people assume it would take 1 second to go out and 1 second to come back, but we don't actually know that. Hypothetically, it could take no time at all to zip out and all the 2 seconds to come back, or the reverse. It could take 2 seconds to go out and no time at all to come back. And some people say, why would it be different? And I don't know, but I don't know why it would have to be the same either, because that direction is not the same as that direction. They are different. Otherwise, we couldn't distinguish them. And there are certain substances where you can make light go faster in one direction than another. Maybe the fabric of space-time is like that, as a hypothetical. Mm-hmm. But my point is you can't actually measure the one-way speed of light objectively. And you might think, well, that'd be easy to do. You have a clock here and you have a clock there, and this clock tells you when to start the light. That one tells you when it arrived, and so you just do it on a one-way trip. But it turns out it's impossible to exactly synchronize the two clocks so that they read the same time at the same time without knowing in advance what the one-way speed of light is. And so what that means is any attempted experiment to measure the one-way speed of light is either already assuming the one-way speed of light in the way it synchronizes the clocks, or it will give the same answer no matter what the one-way speed of light is.
Right. And what you're talking about is the fact that if you take a clock and you move it through space, you're because of Einstein's equations, mm-hmm. that you actually cannot synchronize the clock because it's moving.
Yeah, right. So motion affects the passage of time.
Right.
So moving clocks tick at a slightly different rate than stationary ones. And this is not something we notice in our everyday lives because the effect is very, very small. Mm-hmm. But in order for this experiment, in order to measure the one-way speed of light, it's not good enough to say this clock is almost synchronized with that. It has to be exactly synchronized.
Right.
And that cannot be done. And lest I get millions of emails saying, I think I've thought of a way to do it. No, you haven't. Because physicists have been trying to do this for 100 years. Please read at least 10 papers on this topic, but because everything's been thought of. Yeah. And it's something that Einstein wrote about. He actually wrote about why you actually can't determine the one-way speed of light. And so his solution was to simply stipulate the one-way speed of light. He says, we'll just define it to be, and he preferred it to be the same in all directions, because it makes the math easier. Mm-hmm. He says, and that will define what constitutes synchronized clocks. And that works, but it's only good for certain reference frames. If you have somebody that's moving relative to you, if you think these clocks are synchronized, this person who's moving relative to you will say they're not synchronized, right, using the same method you used. Yeah. So it's not a universal method, it's conventional.
One of the things that I've read, actually I've read your book on Einstein's theory. And then I read a paper that you did on ASC, mm-hmm. and you were talking about using Einstein's synchronization for measuring the date of the creation of a distant galaxy on one side of the orbit of the Earth versus the other side of the orbit of the Earth, using Einstein's theories. And so, can you speak to that?
Yeah. So when the Earth's on one side of the sun, it's moving in one direction in space. When it's on the other side, it's moving in another direction in space. And so, let's say that the Andromedans are tired of putting up with us. Our radio transmissions are offending them, and so they launch an attack against the Earth. Now, when does that attack happen? Well, if you're on this side of the sun, it's happening right now. If you're on the other side, it happened a long time ago, or it hasn't happened yet, because the motion this way, the way you'd synchronize clocks, is different from the motion this way and the way you'd synchronize clocks if you use Einstein's synchrony convention. Now, he was aware of that,
right? Yeah.
And that's perfectly fine. There is no method where you can get everybody in the universe to agree on a universal now, because there isn't such a thing.
Right.
And that bothers folks, because we tend to think of time as absolute. It's the same everywhere. And Einstein discovered that's not the case.
Yeah.
And so there's different. You can push the problem from one place to another, but you can't get rid of it. And Einstein said, let's make the speed of light the same in all directions, and that creates issues where even if two people are in the same place, but they're moving relative to each other, they'll disagree on whether or not clocks are synchronized. Another solution is to let the incoming speed of light be infinite, in which case it takes no time at all for the light to get from there to here. And that allows everyone on Earth to agree on when a distant event happened.
Right. And so in that case, you'd be seeing the whole universe real time.
That's right. Yeah.
Yeah.
And the disadvantage of that is if people lived in a distant galaxy, they would disagree on whether. But here's the cool thing: nobody lives on a distant galaxy, so we're all here on Earth. So the method that the Bible uses apparently is where the incoming speed of light's instantaneous. It doesn't come out and say that, but all ancient cultures implicitly assumed that anyway. And since the Bible was written to be understood at all times, and not just for modern, 21st century physicists, it makes sense he would use that older convention rather than the modern Einstein convention. They're equally legitimate.
That would be true in Western civilization also, that they used an instantaneous type of view of time all the way up until 1600s.
Yeah. Yep.
Yeah. And so, yeah, that's been the case for most of the history of the world. Mm-hmm. And so when the Bible talks about the God made the stars on the fourth day, it would be on the fourth day that we would be seeing the stars.
Yes, had there been anyone there. Yes.
Right. Yeah. Exactly. Okay. So again, can you speak a little bit to the whole issue of the distant light, because we've kind of gone around the bush with this whole thing.
Okay.
And so
the bottom line is, if instead of using the Einstein synchrony convention to define what now means at a distant point in space, if instead we use the older convention, a visual synchrony convention, or what I call the anisotropic synchrony convention. Anisotropic means different in different directions, whereby the speed of light is infinite when it's moving toward an observer. It doesn't matter who the observer is, and half c when it's moving away, because the average has to be c. That's set by God. Can't change that. The one-way speed we can define. And if we define it to be instantaneous, as all ancient cultures did, then there is no starlight problem, because we're seeing the universe in real time, even now. And then the sticking point for most people is they think that I'm saying that the Einstein synchrony convention is wrong, that the speed of light really moves instantaneously in this direction. What I'm instead saying is that the two conventions are equally legitimate. And that's hard for us to comprehend, because we don't think of space and time that way. We think of time as absolute and space as absolute. They're not.
Right.
So so basically, within known physics, the physics that Einstein himself wrote about, you can get light here instantaneously from the most distant galaxies, even today, if you use this anisotropic synchrony convention. And if people wanted to read up on this, it's called the conventionality thesis. It's something that is in the relativistic technical literature.
Yeah, totally worth looking at.
Okay, so for the simpleton over here on this side, if you had light going out, and we can measure that and speed, whatever, and all that stuff, and the same light coming back is instantaneous, doesn't that mean it's going through a whole different set of parameters that affects the light going out? Like its reverse is affecting it differently, where the dynamic of the universe changes properties based off of the direction?
It turns out no. It turns out the properties.
How does that work?
The properties of the universe only determine the round trip speed of light. That's all they determine. The one-way speed will be affected by what synchrony convention you choose. Some people have said, well, no, Maxwell's equations make the speed of light the same in all directions. They actually don't, because when you look, there's two ways of looking at Maxwell's equations, and Maxwell's equations relate electric fields to magnetic fields. There's only 4 of them. They're very simple, and they allow us to explain everything involving electricity, magnetism, and light, and radio, things like that. Very powerful. And there's 2 ways of expressing them. There's what's called the integral form and the differential form. In the integral form, if you look at the integrals, they all have a little circle in the middle. And what that means is you're integrating around a closed path. Okay, so when you're doing your math, you're making a round trip. And therefore, in the integral form, it should be obvious that the Maxwell's equations only require a round trip speed of light to be constant. They don't require the one-way speed to be one thing or the other. It's a little less obvious in the differential form, because the way the differential form is normally written, you solve it, and it does seem like the speed of light should be the same in all directions, the one-way speed. But a guy named Carlo Giannani back in 1980, I think, he derived Maxwell's equations without assuming a one-way speed, and he found they work just as well if the one-way speed of light is different in one direction than another. So it turns out the fabric of space-time only requires the speed of light to be constant in a round trip on a closed path, but it doesn't determine the one-way speed of light, amazingly.
Okay, that's mind-boggling.
It is. It's counterintuitive.
So you're from Boulder, Colorado. Is that the same place that they flew the atomic clock around to make the time experiment, and Greenwich, England, atomic clock to get that there's a 4th dimension as time? Is that the same place, or is that
well, there is atomic clock in Boulder. I don't remember if that's the one they used or not for that particular experiment. But there was an experiment where they flew a plane in one direction and compared atomic clock values, and it verified Einstein's prediction.
Right.
Yeah. This is one of those things that I don't think a lot of people really look into. It's something that I share with my people all the time when when we're talking about the solar system and the universe especially, is the fact that your position and your speed affect time. And that's one of the basics to Einstein's theories. And so in a practical way, we know this is true because of, for example, GPS. So can you speak to that?
Yeah, the GPS, so Global Positioning System. So if you have a smartphone, it uses that to know where it is on Earth. And they do have to take into consideration relativity when they build those things, because the satellites are in orbit. So you have 2 effects. Because the satellites, it's further away from a source of gravity. Gravity causes clocks to tick slower, and so it should tick a little faster. But on the other hand, it's in motion, and motion also causes clocks to tick slower. And so those 2 effects combine, and I forget which one. I think the speed one dominates. But in any case, they do have to build that into the devices when they do that.
Right. Otherwise, they're off.
They're off. Yeah.
And so it's one of those things that you see in physics that's kind of counterintuitive to most of us, because we think that time is the same no matter where you're at. And Einstein proved that time changes depending on where you're at and how fast you're going. And so time is not the same for the whole universe, and that's really kind of the point with your ASC theory. I had a question about specifically the rotation of galaxies.
Okay.
And so this gets into dark matter and that whole issue. And so from my understanding, what they've seen is that galaxies, distant galaxies, are rotating faster on the inside than they are on the outside, and it's not based on Newtonian physics.
Okay. If the stars were the only things that were there,
Right.
then you would expect the galaxy would not be rotating the way it does.
Right.
The outer portions are moving a little faster than you would think. Galaxies do rotate differentially, so the inner portions rotate faster than the outer portions. You would expect it would be the exact relationship that would be like our solar system. If you look at the inner planets, they're really whipping around compared to the outer ones. But the outer regions of the galaxy are rotating faster than you would expect if all the mass is in the stars and gas and dust, things that we can directly detect. And so that's led many astronomers, myself included, to think there's more stuff there than what we can detect.
Okay.
And that's what dark matter is. So dark matter is stuff that we can't see it, but it gives evidence of being there by exerting a gravitational force on the more distant stars in the galaxy, making them move a little quicker than they would otherwise.
Okay, so what are you thinking that the dark matter is?
Oh, I have no idea. But I mean, you know, when you get the socks out of the dryer and you're missing one, maybe it goes into the, I don't know, could be a bunch of dirty socks out there.
That's the answer I want to find at my house. Where's my socks at?
The interesting thing is, whatever dark matter is, it has to be something that we really haven't thought of, because everything else, even though it might not glow in visible light, it should give off, if it has any temperature at all, it should give off some kind of infrared radiation. And we have instruments that can detect infrared radiation, so it ought to be glowing somewhere in the spectrum, and it's not. So the only two possibilities we can think of are either it consists of a bunch of very small objects that are compact and very massive, like black holes or something like that, massive compact halo objects, or it's a new kind of material, new particles that we haven't discovered yet that don't radiate like ordinary matter does, and so these would be called weakly interacting massive particles, or WIMPs. So you got machos and WIMPs. So that kind of it's kind of cute. And the weight of the evidence is toward the WIMP solution, because when we machos should give evidence of their existence, because when they pass in front of a star, they should bend the light from that star. It's called a lensing event, a gravitational microlens, and it'll cause that star to temporarily brighten and fade in a very predictable way. And this is something that I studied when I was an undergraduate, actually. And we do find a few of these, but not enough to account for the dark matter that is necessary to cause the rotation profiles to be what they are.
Okay.
So that leads me to believe that the WIMP is probably on the right track.
Okay.
I used to be a macho man, but now I'm a WIMP.
So, you were talking about machos, and from what I understand about this, they're talking about this dark matter being in the halo around a galaxy, specifically spiral galaxies. Those are the ones that are really seeing it in, right? Yeah, am I right? Okay. And so those halos would be, you're talking about the outer edges of the galaxy. So wouldn't we be in our galaxy right in the spot where we would be able to?
There should be some dark matter in our vicinity, and none's been detected. So yeah, it's a puzzle.
Yeah. Okay.
That's why they're weakly interactive massive particles. They're difficult to detect. Whatever they are, they're difficult to detect. They only betray their presence by their gravity.
Okay. So, okay. The other thing I wanted to talk to you about was, and this is stuff that people hear about in the newspaper, but I don't know that it gets explained very well, is dark energy. And so, from my understanding, dark energy is something that they're postulating because they've seen that the expansion of the universe is increasing in speed. And so, is that correct? Is that?
It's a possibility. Yeah,
okay.
It's a possibility. I'm less certain of dark energy than I am dark. I'm not 100% certain about dark matter, because it could be that the laws of physics are not exactly what we think. But they've worked so well in our solar system, we feel that we're probably on the right track there. So I think my flag is in the dark matter camp. Dark energy, there's two reasons why you might think that it exists, and one of them is the observational evidence that when you look at light from distant supernovae, and you calculate how far away they are based on their brightness, and then how far away they are based on their redshift, there's a discontinuity that would indicate that the universe has changed its rate of expansion to where it's actually expanding faster now than it was in the past, or it's accelerating basically. And dark energy would do that. There's also a theoretical basis for it too. It turns out that Einstein's equations in general relativity, which include gravity, they allow for empty space to have a little bit of mass to it. We tend to think of space as nothing, but it's not nothing. It's something, because it has dimensions, for one thing. Space is three-dimensional, and there's one dimension of time. So space is not nothing, it's something. It has dimensionality. It allows electromagnetic radiation, so it can have magnetic fields. It has properties, and therefore it's not nothing. And if this empty space, what we think of as empty space, has a little bit of mass to it, that would be called dark energy, basically. And so Einstein's equations allow for it. It has to be pretty small, or we would notice it locally. But it is a possibility. I think the observational evidence for it is possible, but there are other ways to interpret it too.
Okay.
So in any case, it's a possibility. It's an intriguing possibility.
Okay. All right.
Yeah.
All right, so this might be like 10 questions in one, but
Oh, boy.
age of the Earth from space or an astrophysicist point of view. When I grew up going to school, the whole Darwinian evolution that the world's millions or billions of years old, and they would use things like the simple cell theory and go off on this chart, and that's what they taught us. Being a Christian, then I got into creationism, and now we're at the point, at least technologically wise, where there's so much evidence that it just seems to be a mute point of an argument, where you're talking about age of the Earth or evolution specifically. But from what you see, young Earth, old creationism, whatever people like to throw in there, how do you see it from your scientific background?
Well, biblically, there's no doubt the world's not millions or billions of years old, because human beings are made on the sixth day. Yes, those are ordinary, approximately 24-hour days, each one bound by an evening and morning. God couldn't be clearer about that. Our work week's based on it, according to Exodus 20, verses 8 through 11. So yeah, they're ordinary days a few thousand years ago. So that's the best evidence for a young Earth, is we have the birth certificate of the universe. It's eyewitnessed by God himself. And in fact, this section in Exodus 20, verse 11, where it says, "In 6 days the Lord made the heaven and the earth, the sea, and all that's in it," that was written with his own finger in stone.
Yeah.
So there's no doubt about that. And he knows, he was there. Regarding the science, all science, well, let me back up a little bit. Technically, you can't measure the age of something scientifically unless you observed its origin, because science requires observation. That's one of the keys. Either observation and experimentation are the hallmarks of science. You can't observe the past; it's gone. So science can't prove the age of something unless it was observed. But that being said, you can use science to make some guesses about the past, and there's nothing wrong with that. But people have an undue amount of confidence in scientists' abilities to extrapolate on what allegedly happened millions of years ago, when they can't even predict the weather 2 weeks in advance. So that's something to keep in mind. Is there are limitations. Science works really well in the present in determining what happens now, but when you extrapolate about the past, not so much. But I can again use one of these reductio ad absurdum arguments, where we'll say, okay, let's assume your assumptions. Uniformitarianism, rates and conditions have generally been like they are today, and let's take a look at some present processes like the decay of Earth's magnetic field. The Earth's magnetic field is waning. We've been able to measure that for a century and a half now, and it appears to be an exponential decay. So it started out strong, and then it's getting weaker and weaker and weaker. If you run it backwards based on the current decay constant, you run it back 6,000 years, the Earth's magnetic field would have been about 20 times stronger at creation. That'd be nice. Your compass would work better. Less cosmic rays, because the Earth's magnetic field acts like a shield. It deflects cosmic rays, which are bad for your DNA. So less disease, that's great. But if you run it back even 60,000 years, because it's an exponential decay, it gets really massive. At 60,000 years, it exceeds the magnetic field of a neutron star, which is enough to rip the atoms of your body apart.
Wow.
So that's a pretty tight constraint. And we're not even talking a million years, we're talking 60,000 years. That if the Earth were even that old, the magnetic field would be beyond reason. My secular colleagues say, oh, well, it's not an exponential decay, it flips. We do think it flipped during the flood year because there was something the plate tectonic activity would have done that, but there's no mechanism for that today. It appears to be just an exponential decay. So again, based using uniformitarian assumptions that the decay constant's always been what it is today, you run it back, can't be older than 60,000 years, or carbon dating for that matter. A lot of people think carbon dating gives millions of years. It never does. There are other methods that secularists use that they think gives the millions of years, but not carbon dating. Carbon dating is based on the decay of C14, most carbon C12. There's a variant, C14, that has 2 extra neutrons, which makes it unstable, and it will decay into nitrogen with a time scale of about 5,700 years. And so if the Earth were even 1 million years old, there shouldn't be an atom of C14 left. Let alone, it's produced in the upper atmosphere, but there are things that we find buried deep in the rock layers that cosmic rays can't penetrate down there. We find C14 in them. They can't be millions of years old. Dinosaur fossils, we've dated dinosaur fossils. If there's enough carbon left in them, you can carbon date them. And every time we found C14 in them, which limits their age to thousands of years.
So why did radiometric dating get connected with the ages so much? Why did that get popular?
Because not so much carbon dating, but there are other methods that if you make certain assumptions, they do give age estimates of millions or billions of years. And the reason those caught on is because they're just about the only thing that gives an estimate of millions or billions of years. And so
Okay.
that they give an answer that the secularists like, is what it comes down to.
So, okay, that's my next question is, we're looking at this and you're not, I mean, it's a logical, scientific, looking at the evidence to get your theory or your answer. Why is it, and is it because they have a worldview and they're trying to fit the science into that? And being in the fields, is it an overwhelming secular view compared to somebody who is either a believer or not a believer, but just examines the evidence for what it is instead of trying to force fit this stuff, where even a logical look at it doesn't make any sense? Why are you trying to do that if it's not part of your worldview that you're jamming in there?
Everybody has a worldview. Scientists are not an exception to that. Everybody has presuppositions that they bring to the table when they examine the evidence. And I know people think that scientists are supposed to be very objective, and I realize we should be as objective as possible in the sense that we shouldn't bring in unnecessary presuppositions. I get that. But the fact is we all have a worldview. And the person who thinks he doesn't, the person who says, I'm objective, I don't have these presuppositions, I don't have beliefs about how to interpret the evidence, I believe it should be interpreted neutrally, that's a belief about how to interpret the evidence. So you can't get away from it. Right? So the neutrality is itself a belief, and you can't get away from having beliefs about the evidence. So yeah, there's no doubt. The reason that secularists come to these conclusions is they already have that way of thinking in their mind, the millions of years, and that goes all the way back to the Greeks. The Greeks believed in a very old universe, and that influenced the church. And by the 1700s, there were some scientists, and not just scientists, but just secularists, who wanted to divorce the science of geology from Moses. I can show you quotes where they've said that, which basically means the Bible. They were sick and tired of the tremendous success that science brings when you start with God's word and you interpret the data accordingly. So I don't blame my secular colleagues for having a worldview. I have one too, but I would ask them to examine their worldview and point out that it doesn't make sense of the scientific method itself. My worldview does, because I have a God who upholds the universe in a consistent fashion. He does that for our benefit. He's not required to. He does that for our benefit. And he made my mind. He gave me the capacity for rational thought. He made my senses, and so my senses are basically reliable. Science presupposes all of those conditions. But if the universe were just chance, if I'm just rearranged pawn scum, none of those things can be counted upon. People assume them, but what's your rational basis for it?
Yeah.
So I take the conversation back a step further and say, yes, we both have our worldviews. My worldview makes science possible. You're stealing from my worldview when you do science, because your worldview doesn't make sense of science.
Right. Are they, okay, last question on this series. Are they starting to take a step back or be on the run or lose, I don't know how else to say it, when you're talking about goo and dinosaur bones, the age of the earth, some of the stuff we've already talked about? Are they starting to see these massive problems that they didn't know were there? They're just starting to be on the creationist side and look at it as like, this is starting to get overwhelming? Or no, they still have their...
It really depends on the individual.
Okay.
But worldviews are powerful things. And
Yeah.
if you are committed to the idea that there's no God, then there is no evidence that will persuade you otherwise.
Right.
There's nothing.
I just didn't know if there's a paradigm shift in the scientific community from 20 years ago based off of the technology.
I would say no.
Okay.
They're certainly aware of the problems, but they're like, well, that's science. We don't know everything. That's true. That's true. You don't know everything.
Yeah.
But these things that are problems in your worldview are features of my worldview. They make sense.
Right.
And there are some people that you can tell the Holy Spirit's working on them, and they come out of that. And and I've met scientists who used to believe in millions of years, and I've talked with them a little bit. Now they don't. Now they believe in the biblical timeline. So we are seeing success of individuals. Whether or not it'll be successful as a movement, only God knows.
Yeah.
I wanted to talk a little bit more about C14 versus like potassium argon and those kind of dating methods. You made the point that C14 decays away in 5,700 years. Well, a half-life of 5,700 years, and so and you made the point that after a certain amount of time, there'd be no more C14 in something that's been isolated from the atmosphere, basically.
Right.
So what's that amount of time?
Before it would be undetectable, probably about 100,000 years before our instrumentation could detect it. And if you run it a million years, because the decay is so fast, if you took the entire Earth and assumed it was 100% C14, after 1 million years, you'd not have one atom left. I didn't believe that until I did the calculation. There's one atom left. I didn't believe it's true. Yeah.
Wow.
Yeah. So anything that's buried, and I'll grant, there's new C14 They should if it was buried for even 1 million years, there should be 0 C14 atoms in it.
Right.
Coal beds, which are evolutionists believe to be hundreds of millions of years old, every chunk of coal you've ever tested has C14 in it. Everyone.
Yeah. So whenever you're having a conversation with somebody about radiometric dating, if there's radiometric dating that they'll do on lava rocks, and so that's like potassium argon and some of the other methods. But when you're talking about C14, you are dating organics. And again, when you're talking about dating organics, you can't have any C14 left in the specimen. If it's been separated, again from the atmosphere, buried, you can't have any C14 after 100,000 years. Mm-hmm. And so if you find it in dinosaur bones, then that means...
They're nowhere near millions of years old.
Right,
yeah,
exactly.
Okay, so back to my last question. You see that, they see that, that's where the evidence is. What do they do with that when they're presented with that?
Well, let's say there must be some kind of contamination that's introduced new C14 into it. That's what they say.
Yeah, it's crazy.
Haven't they found C14 in diamond?
Yes, we found C14 in diamonds. Yeah.
Okay, so how'd the contamination happen? Yeah, exactly. That's...
One argument that I've heard them make is they'll say, well, radioactive processes in the Earth will generate new C14. And they can. It just turns out you'd need 13,000 times more radioactivity to be able to generate it in the quantities that we're finding.
Well, maybe there's one hot spot down there.
Yeah.
Where all the diamonds are
Except
made.
we find it everywhere is the problem.
Yeah.
So the Earth's just not that radioactive.
Wow, yeah.
I wanted to ask you, from your background and your specialty, what's the most effective argument as an astrophysicist or whatever in the biblical view of creation? Like if you had 5 minutes, what's the one thing that you would hone in on as proof of a biblical creation?
It's not the argument people would expect. They would expect me to give an argument from irreducible complexity or something like that. The fact that all the parts of an organism have to work together or the thing fails, that defies any kind of piecewise evolutionary progress. I think that's a good argument, but it's not the one that I think is bulletproof. The one I think is bulletproof is the fact that the scientific method is based on biblical creation. There would be no reason to trust in the presuppositions of science if the Bible were not true. And one in particular that I would bring out, and it takes a conversation to develop this, but
Sure.
This principle of induction, whereby we derive a universal pattern by looking at certain specific instances. And science does that all the time. We observe that this thing drops at a certain speed, we drop it again, drops at a certain speed, and we eventually say, you know what, it always drops at that speed. We write down laws that characterize the universal behavior based on a few specific instances. And as a Christian, that makes sense because we have a God who has imposed patterns on nature. And we can look at instances of those patterns and derive the whole pattern. But if the universe were chance, if it's not upheld by a mind at all, there's no reason to expect any patterns. And so the fact that the pencil has fallen the last 3 times does not mean that it will fall the next 3 times in a chance universe. In a chance universe, anything could happen the next time you drop. Next time I drop it, it goes up instead of down. It's a chance universe. And so the idea of using past experience as a basis for what is likely to happen in the future, that's a creationist concept because God has promised a certain degree of uniformity in nature. That doesn't mean that rates and conditions are constant, but it does mean that at the basic level, what we might call laws of nature are consistent over time. And we have a promise from God that that'll be the case. In Genesis 8:22, God promises the basic cycles of nature, the day and night cycle, the seasons, will be as long as the earth remains, as they were in the past. And so that tells me that the sun will rise tomorrow. It tells me that if I do an experiment under certain circumstances and get a certain result, if I do the same experiment under the same circumstances, I'm going to get the same result every time. Now, everybody assumes that you couldn't do science without that, and yet there is no secular basis for assuming that if the conditions are same, you'll get the same result. In a chance universe, there's no guarantee of that at all. And the philosopher David Hume was reduced to utter skepticism on this very issue. He wanted to know, how is it we know the sun will rise tomorrow? Everybody knows the sun will rise tomorrow. He wanted to know what is the epistemological basis for that. How do I know that? And he, from his secular viewpoint, he could not come up with an answer. See, I can answer that. I got a promise from God. God's beyond time, so he knows what's going to happen tomorrow. And he's told me that the day and night cycle will continue as long as the earth remains. So yes, I know there will be a sunrise tomorrow. I have a rational basis for that, and therefore for science and the scientific method. Whereas my evolutionary colleagues are relying on Christian presuppositions when they do their science while rejecting Christianity. That is irrational. So they're stealing from my worldview to support their own, and that is
Yeah,
irrational.
I
It's
really-
very powerful.
I really like the explanation you get, because the message they're using points to a designer, points to somebody in a
It presupposes one. It presupposes that God is upholding things in a consistent fashion. It presupposes our senses are basically reliable, such that what I see is really corresponds to reality. I'm not just a brain in a jar being fed in like in the Matrix, and all this is just kind of fake. It's a simulation or whatever. No, in the Christian worldview, I can say, no, God doesn't do that. He's not the author of confusion. He's made my senses, so of course they're going to be reliable. He's given my mind the capacity of rationality. I'm made in God's image. I can look at the evidence, consider the choices, choose the best. If I'm just chemistry has no choice. So the whole idea of science doesn't make sense in an evolutionary worldview.
Yeah.
And that is very devastatingly powerful. And no one will ever be able to defeat it because it's a biblical argument, because the Bible says the fear of the Lord is the beginning of knowledge. You want to know things, and that includes scientific knowledge, you have to start with biblical presuppositions. So no one will ever defeat that argument.
That's awesome.
That's a great one. I heard a joke a long time ago about scientists coming up with creation of life. And they were going to start with dirt, and God said to them, "Get your own dirt." Yeah, it's exactly the same kind of argument. You don't get to use those presuppositions if you don't believe them. And I like that a lot. When you look at the situation with, for example, kids in high school today, kids in college today, the things that they're being taught. Where would you place that as far as factual knowledge? I realized, when I look at what I learned in college, it's not only out of date by 30 years now, it was out of date by probably at least 10 to 15 years as far as the knowledge went at the time that I was in college. And so I know that knowledge is increasing as time goes on here, and it's almost exponential. How far behind do you think kids are and then we're in America. How far behind do you think kids are in college now?
Well, it's hard to know, but this Common Core movement has not helped.
Yeah.
If there's a more confusing way to do math than Common Core, I haven't found it. It's crazy. And, it used to be in schools you'd teach kids how to do things and how to do math and so on, and now we teach them that everyone's special and everybody's a winner. And so we have a group of people coming out feeling very entitled who know nothing. Right. And that's an issue. I'm not a fan. I'm just going to say I'm not a fan of public schools. And if you're a teacher if you're a Christian in a public school, God bless you. You're doing a good service. But if you're a parent and you have students in public schools, I'd consider pulling them out, because I got to tell you, it was bad when I was in school, but it's much worse today, because they're going to get some good information, but at the same time, they're being taught a worldview. They're not just being taught. See, people have this conception that public schools are neutral. They're not. They're taught from a very secular perspective. Even the subjects that are chosen, they don't teach logic anymore in schools, and I think that was a necessary prerequisite for teaching things like evolution, because you don't want to be able to think through those things very carefully, really. Right. And so evolution's taught as fact. History is taught from just its dates and times, rather than, wait a minute, this is God's plan unfolding in the world. It's His story. Grammar and things like that. When I was in school, I never really appreciated things like grammar, the English classes. I liked science, but English. If somebody told me though that things like synecdoche will help you understand the Proverbs and the Psalms that use those figures of speech, boy, that would have energized me tremendously if I'd have realized, I can better understand what God is communicating to me if I know something about the English language. Yeah. And that would help me to understand the original languages, Hebrew and Greek and so on. So I try to teach everything from a uniquely Christian perspective, because that's the right perspective, that's the right worldview. And I find that kids respond to that very positively. Yeah. So I wish I'd have had a different education than I did. But the Lord, the Lord can take the weak things of this world and
Right. We have a private school here, and one of the things that happens is parents will pull their kids out of public school and put them in private school. And man, a lot of times the kids can't read. They'll be in 3rd and 4th grade, and they're having a really hard time. And then, as you said, Common Core, the Common Core math, they have no idea what they're doing. Yeah. and can't get the answer right in Common Core, much less any other way. And fortunately, it seems like specifically with math, it's pretty easy to catch them up pretty quickly, at least in the elementary stages. But yeah, I agree with you. That's a pretty scary thing. Anything else you'd like to share with us about favorite arguments? Cool. Oh, you know what? I did have a question.
Okay.
We're seeing further and further into the universe, and we were talking about this a little bit before we got started. And so with the Hubble Space Telescope, we're seeing galaxies that are further and further away. Mm-hmm. And so the one that's furthest away, they think the light took off about 13.4 billion years ago. Mm-hmm. One of the things that I know that they've been looking for is that they would see younger and younger, so to speak, galaxies as they look further and further out. Mm-hmm. Has that been happening?
No. What we find are fully designed galaxies at tremendous distances. And that was astonishing. The first time the Hubble Deep Field came out, mm-hmm. and astronomers were expecting to see galaxies just kind of starting to form, and we saw beautifully fully designed galaxies at tremendous distances. And to my mind, and I need to do a formal study on this, but to my mind, the spiral wrapping looks about the same in those galaxies as it does for nearby galaxies. There are some slight differences. Galaxies at a distance tend to be a little bluer than nearby galaxies, and there are higher proportions, I think, of irregular galaxies at distances. But in terms of galaxies just starting to form, we don't see it. Mm-hmm. We see perfectly designed galaxies at all distances that our technology is currently able to reach.
Wow.
How about that?
Yeah,
almost as if God just spoke them into existence.
Yeah, and we're seeing it in real time.
Well, that's true. Yeah, yeah.
That's interesting. Okay, and so the Webb Space Telescope is about to be put up, and I know that it's going to be more of an infrared telescope.
Right.
It's going to be skewed towards that end of the spectrum. Because they're starting to look at things, well, they want to look at things that are further and further away, which are going to be skewed towards the red. And so, any predictions about what they're going to be seeing?
I think we'll continue to see galaxies at increasingly greater distances. They will have about the same spiral wrapping as nearby galaxies, indicating the same age. That's my prediction. That we'll find evidence of magnetic fields at increasingly great distances. Magnetic fields are an indication of youth because magnetic fields decay with time. They do. So there's already some evidence of that with some of these extrasolar planets that we're finding that they have magnetic fields, and that would not make sense in a secular billions of years point of view. So there's some predictions about what we're going to see. Things that will continue to surprise the secularists, but will delight creationists in God's creativity and His ability to do whatever He purposes.
Yep, that's cool.
Yeah.
Good.
I'm good.
All right, we are out of time. Jason, tell these guys where they can find you, where you're at. I know you write books and stuff, so whatever information you want, they can reach and get a hold of you, social media, or where are you at?
Sure, yeah. Best way to get a hold of us is to go to the Biblical Science Institute, and it's just that word, biblicalscienceinstitute.com. That's our website, and you can get all kinds of wonderful information there. There's a lot of free articles available. We have a web store where you can get books or DVDs, things of that nature. We do have an online forum. That's the only thing that, if you wanted to contribute financially, that's the only thing we ask you to do to get on that forum, and then you can interact with me and other creationists and ask questions or whatever. So it's a great opportunity. We have a podcast too. If you go to the top, there's videos. There's a sequence of podcasts that I would like to do more of. I haven't had the time lately, but they're kind of irregular. But yeah, so there's a lot of stuff there. So biblicalscienceinstitute.com.
All right, and thank you guys for tuning in. Hopefully that blessed you. I'm sure it did. If you want to hear more from Jason, he will be speaking tomorrow here at Calvary Chapel Tri-Cities for all three of our services. So you guys can come out. And what
do you... the evening service.
And the Sunday evening service. Yeah, that's right.
With a Q&A.
Oh, you're doing Q&A too? Cool.
Yeah.
So there you go. Tell them, can you give me just a brief synopsis of maybe your talking points that you're going to have tomorrow?
Yeah, tomorrow morning I'll be talking about how astronomy reveals God's glory and refutes the Big Bang and the billions of years idea. So some of the stuff we talked about here, but other stuff that we didn't get to. So it'll be good. And in the evening I'll be talking about other fields of science like genetics and geology and paleontology and how that confirms biblical creation and a worldwide flood.
All right, so come on out here, Jason, and we would love to have you. If you guys have questions for us, you guys can email me crosswalkradio@gmail.com. You guys can send a text or leave a voicemail, 707-872-7677. We normally do our True Set Free on Wednesdays at 3:30. This is kind of a special because Jason's in town, so you can catch us normally during the week. Other than that, that's all we have for you. Thank you so much, man, for coming and hanging out with us. It was a pleasure talking to you, and we'll hear from him tomorrow.
Thanks.
All right, God bless you guys.